Okay. So yesterday what we had discussed, Priyanka, means up to compensation theorem we did it now, right? Up to compensation theorem, I think we had completed. Right, we had completed up to compensation theorem, no? Just
Yes,
wait. Just wait. Oh, I didn't share my screen now. Let me share my screen. Okay. Yeah. So we had completed up to compensation theorem, I think. So we are going to study Telegon's theorem today. Okay? Telegon's theorem. So Telegon's theorem basically it's tell about the power. Okay? Please mute your noise. Okay? So today's topic is about today is the eighth topic and we are going to study about Tele Telegon's theorem. Okay? So now people are coming. So what I am telling, today we are going to study about the Telegon's theorem. So what is the meaning of a Telegon's theorem, guys? Telegon's theorem we have to study. So actually the meaning of a Telegon's theorem is what you know. In in any network, okay, either it be a linear network or non-linear network, okay, as it is bidirectional network or unidirectional network, any network, okay, time variant, time invariant. So in any kind of network, the total power, the total power, the total, you must write total instantaneous power. Okay, the total instantaneous power, instantaneous total instantaneous power absorb, in a circuit must be equal to 0. So what is the meaning of total absorbed power in a circuit must be equal to 0? Its meaning is that is your absorbing power must be equal to your delivering power. Okay, your absorbing power must be equal to your delivering power. Okay, you can write like it, that is at any instant of time, at any instant of time, the total power absorbed in the circuit, the total power absorbed in the circuit must be equal to the total power delivered in the circuit. Power delivered in the circuit. So basically it is, for the verification of a Telegrams theorem we use KCL or KVL. Okay, so write it down. For verification of Telegrams theorem we use KCL and KVL. So that topic I already taught you in the first class, and we are seeing that our absorbing power was coming coming is equals to the delivering power. So that's we are doing the sum up and we are getting the result 0. Okay, so Telegram theorem is nothing but it's just based on the law of conservation of energy. Telegram theorem is nothing but it's just a law of conservation of energy. So in a Telegram theorem, so what Telegram theorem tells about, the total absorbing power will be equal to total delivering power. Okay, and if you are checking the power in a instantaneous power, the total instantaneous power in a circuit must be equal to 0. You have to remember this point. Okay, total instantaneous power in a circuit must be equal to 0. And write this. Telegrams theorem is based on the law of conservation of energy. So I am giving you a simple example. Suppose you have a particular circuit, positive, negative, okay, and you have a 1 resistor, 2 resistor. So suppose it is delivering for 50 watt. This particular, it is delivering 50 watt. So this is my P deliver, and this is some R1 and this is some R2. So it is absorbing, P absorbing is suppose 25 watt, and this is P absorbing is also is 25 watt. So what it's coming, your P deliver is equals to total P absorbing. So that means overall power is nothing but P deliver minus total absorbing power. That is total delivering power minus total absorbing power equals to 0. This is known as instantaneous power at a particular time. Instantaneous power. So your instantaneous power will be 0 according to Telegrams theorem. Okay, so this is just what I want to tell you about the Telegrams theorem. So Telegrams theorem is just basic things, means it's nothing. In a Telegrams theorem, overall power will always be 0, and it's applicable to any circuit. Okay, this thing is applicable to any circuit. Now we are studying the next topic and the last topic of the theorem, that is maximum power transfer theorem, and it is a very important topic. So maximum power transfer theorem. So it is one of the important topic, guys. So suppose you have a particular network that is linear and bilateral. Linear, or suppose it is not bilateral, it's a bidirectional. Bidirectional I'm taking. Okay, bidirectional. So linear bidirectional network we are taking. So if I'm taking a linear bidirectional network, then you have to find the maximum power in this particular network. So how you will find the maximum network in this particular network? So some load will be connected. This is your RL. This can be equally transformed into, this particular network can be equally transformed into RTH and VTH. It will have some load RL. Okay. So guys, what is the value of, we converted this network into VTH and RTH. So I am asking, this is my load. So this is my load. This particular part is our network part. What we had converted into VTH into RTH form. So what is the I value? VTH divided by
RTH.
RTH plus RL.
Yeah, plus RL.
This is my I value. And what is power? I square
I
in
square.
I square into RL. We have to find the power of load. Okay. So if you will substitute these things, this power, what you will get? Power is equals to VTH square divided by RTH plus RL square into RL. Right? You will get these things if you substitute the value of I in this. Okay, for finding the maximum value of a power, for finding the maximum value of power, what we do? We need to differentiate dou P by dou RL with RL with load resistance. So if you will differentiate with the load resistance, what value you will get? Differentiate it. So VTH square is, VTH will be common. Okay, and RL by RTH, these things are there. So first RL will be differentiated. You will get RTH plus RL the whole square minus RL into 2 RTH plus RL divided by RTH plus RL whole power 4. U by V, dou U by dou V I had used. Okay, so means if you have a differentiation like this, means U by V, so you know now how to differentiate U by V. U by V differentiation, I think you all guys know this thing. Okay, so this is the basic things, means we are differentiating. VTH square is common, so I just took the VTH square is common. First I differentiated this RL, so RL differentiation will be 1, and this is 1, and this RTH plus RL square will be common here. Then it will minus sign will come. Then I will differentiate this part. So I will if I'll differentiate this part, I will get 2 RTH plus 2 RTH plus RL, and this RL will be multiplied, and this. So if you will take RTH plus RL common, what you will get? What you will get if you will take RTH plus RL common? You will get RTH plus RL the whole square minus 2RL minus 2RL. Guys, if you will take RTH plus RL common, what you will get? Divided by RTH plus RL the whole cube. Okay, RTH plus RL will be cancelled out. So you are getting this particular result, right? You are getting this particular result. So what is the value of basically what value you will get it if you will solve this particular integration? If you will solve it, what value you will get it? Guys, see, RTH plus RL the whole square. If you will differentiate it, what you will get? 2 RTH plus RL into, again if you will differentiate it, you will get it 1. So this value we are getting here, and RL is multiplying here, and the value after solving this we are getting something like this: RTH plus RL the whole square is equals to 2 RL. All the things will be 0, right? So 2 RTH square plus this will be RTH square plus 2 RTH RL plus RL square equals to 2 RL, right? We'll get this only. Okay, we'll get this things only, na? Oh, I did some mistake here. RTH plus RL means, because we are taking the common part, na? See, this RTH plus RL we are taking common. Okay, RTH plus RL we are taking common. So RTH plus RL minus 2 RL divided by RTH plus RL whole cube, it is multiplied with VTH square is equals to 0. So what value you will get? RTH plus RL minus 2 RL is equals to 0. So what RTH value you are getting is equals to RL. So this part is all. Okay, so you understood, means we did the UV differentiation of a U by V differentiation. So U by V in a U by V differentiation, what is happening? U by V differentiation, what is happening? First we differentiate our which term? Our U term. If you, yeah, so du by dv is here. Yeah, du by dv is here. So what you will do in a UV differentiation, you will differentiate first du part, v will be constant, then minus u part, dv will be constant divided by v square. So we use the same formula. If you use the same formula, you have P is equals to VTH square divided by RTH plus RL square dot RL, right? So this VTH, this particular VTH is constant, okay, and RL divided by RL you are basically, so I just took it out, and RL divided by RTH plus RL the whole square if you will differentiate. So what is your U? U is this one, and what is your V? V is this one. What is the differentiation of RL? 1, and V will be come RTH plus RL the whole square, like this only. If you will differentiate RTH plus RL the whole square, what you will get? 2 RTH plus RL. And what is your U? U was RL, so RL. And what was your V? V was RTH plus RL the whole square, it will become 4. Take RTH plus RL as a common, you will get this result: RTH plus RL minus 2 RL is equals to 0. So RTH will be equal to RL. So what is the conditions we are getting for a maximum power transfer theorem? Your load resistance will be equal to your Thevenin's resistance. This is the condition for maximum power transform theorem. Okay, now if you put the value, what value you got for the power? V divided by RTH plus RL the whole square into RL. So RL value what we got? Equal to RTH. So substitute the value VTH square divided by 4 RTH square into RTH. So what value you are getting for a maximum power? P maximum is equals to VTH square by 4
4
RTH.
RTH.
This is your maximum power transform theorem. Understood, guys? Priyanka, you understood?
Yes, sir.
Okay. So this is the maximum power transform theorem. It's a very easy. Wait. So now, okay. So this is very important. This was the very important part. Okay. This is the very important part. Now you need to find for what value of a RL the maximum power will be transferred to it. Okay. So you have a circuit like this. This is your 4 ohm. This particular is your 6 ohm. This is your 4 ohm. This is your RL load, and this is your 1 ohm. Okay, you are connecting positive negative 10 volt here. So what they had asked, they are asking what is the RL value for this circuit, so that you will get P maximum. So how you will do it, guys? How you will do it, guys? You need to find the RTH value. Okay. So you need to find the RTH value. So for finding the RTH value, you will open it. RL will be get opened, and from here you have to see the things. Okay, and this will become short circuit because it is independent source. Okay, so it will become short circuit. This part you are getting as a short circuit part. So it's a short circuited, and here it was some resistance, that is 1 ohm, and this is your A, this is your B. So guys, you need to find the value of RAB. So find the value of RAB and get the result. Okay, this is A, this is B. So if I am taking this part, this is B, means this is also B, right? This is A, this is B, so this is my also B, and this I am taking as a C point. Any other point? No. So how you will get the result of this particular thing?
Rearrange the diagram.
We use the diagram.
Rearrange the diagram.
Okay,
As
okay. Analyze the diagram, right?
yeah.
Okay, so you can do one thing also. You can convert this delta as a triangular, means as a star. You can do this part, these things also. It's up to you. how you want to solve this particular circuit. It's totally up to you. So guys, hmm, so these four, this particular, see, if you want to use the diagram also, you can use it. This is B part. From B to C, what it's connected? 4 ohm resistor. B to C. Any other connection is there from B to C? Yeah, 4 ohm resistor is there. We are connecting 4 ohm resistor. From B to A, any connection is there? 6 ohm resistor is there. A, okay. And from B to A and A to C, any connection is there from A to C? A to C, we have 1 ohm on this part. So 1 2 3 4, 1 2 3 4, and we have to see from here, from AB. So this is parallel part, so you are getting 2 ohm, and this is 1 ohm, and this particular is your 6 ohm. This is your A, this is your B. So this will be 2 plus 1, it will be in series. This is your 6 ohm, from here you are seeing, and this particular is your, this particular is your 3 ohm resistor. So it's 3 ohm resistor, it's 6 ohm resistor. This is A, this is B. So what is the value of a 6? 6 and 3 are parallel, so 6 into 3 divided by 9. 3 into 3 by 2. So you are getting RAB value is 2 ohm. So for maximum power theorem, what will be the value of RL? RL will be equal to your RTH value, that is 2 ohm only. Understood everyone? Priyanka? Prasanna? Understood?
Yeah.
So if you understood, just try to this question. Suppose you have a figure like this. This particular is your figure. This is your RL figure. This is 9 ohm. This particular is your 6 ohm. This is 2 ohm. This is 3 ohm. And here it is given, the part is 2 ohm. And here it is given, the part is positive, negative 10 volt. So you need to find the maximum power dissipation. Find maximum power in RL. So for finding the maximum power in RL, what you will do?
Short the RL.
RL also and VTH also. You need to
V.
find, yeah.
Yeah.
So okay, if you want to do, then it's fine. So if you solve the value for V, first we are solving the value for V. So what we need to do? Open it. So it's open. So this is open. So I'm assuming this as a this as a B, means VTH. This is my VTH. I'm assuming this particular as a ground. So if I'm assuming this particular as a ground, or don't need to assume ground, it's up to you. It's open like this. Okay. So VTH, I'm assuming this point, from this point to this point is my VTH. So VTH is what? VTH is your VA minus VB. Okay, assuming this particular as a ground. This is my V1. Okay. So guys,
So that is balanced, right?
No,
9 into
it's
2
not.
equal
We
to 6.
cannot say here as a balance and all, because here na the thing is that we had opened the circuit, so we cannot say it's a balance. Or now we cannot go for a balance bridge because we are finding the VTH value. Okay, so see, so understood the point. I'm just taking this as a V1 point, and this is this basically the here no current will flow. So you need to, you are getting the circuit like this, a simple circuit you are getting like this. It's not that much tough. This I am assuming as a point, and this I am assuming as a B point. This is your 2 ohm, this as a 3 ohm, this as a 6 ohm, this particular is your 9 ohm, and this as a 2 ohm, this 10 volt. Okay, although we had opened it, we just opened it, so so there is a no need to use now the balance path and all. So just find the KVL, use the KVL. You have a V point na, so V minus 10 divided by 2 plus V by 8 plus V by 12 is equals to 0. If you will solve this, what value you will get, guys? V value. If you will solve this, what value you will get? What V value you will get? Take the LCM 24. Okay, 24 you are taking. Right. So what I am telling, if you are using the balance bridge, so what value you will get? The V value you will get. Prasanna, solve it and tell me the answer. Because we have to start the transient part. Okay, network hardly it will take 3 4 classes. All the things is completed. Calculate it, Prasanna. How much you are getting the V value after solving this? 24 na. So 24 is coming, so 5 15V minus 120 plus 2V, so 17V is equals to 120. So V is equals to 120 by 17. All are getting like this one, or is this wrong? See the calculation.
Yes, sir, that is correct.
It's correct, no? Okay, if you got the value of a V is 170 divided by 20, so apply the voltage divider. Here it is your reference. Here it is your reference. Apply the voltage division rule. 120 by 17, na? Yeah, 120 by 17. Apply the voltage divisor rule and get the value of a VA. So VA will be 120 by 17 into 6 by 8.
8. 6 by 8.
And what will the value of a VB? VB will be equal to 120 by 17 into 9 by 12. Right? And what will the value of a VA minus VB? Take 120 by 17 common, 6 by 8 minus 9 by 12. So 120 by 17, 6 by 8 means 24. Again LCM it's coming 18 minus 18. So what value you are
So
getting?
why you are considering a 6 ohm resistor and 9 ohm resistor? Why not 2 and 3?
Because if I'll consider, see this is my 2 and this my 6. Okay, this particular is 2 and this particular is 6. Voltage across this is how much? 120 by 17. So this is my A point and this is my ground point. So what is VA value? VA minus 0. This particular part na.
Yeah, got it.
So for finding this particular voltage, so I have to do what? 120 by 17 into this particular resistance 6 divided by overall
6 by
resistance.
8.
So what the value of a VAB we are getting? 0. 0 volt. Although we got the value of a 0, there is a no need to find the RTH and all. Pmax will be equal to VTH square divided by 4 RTH. Put the 0 square divided by 4 RTH. You will get Pmax as 0. Right guys? You will get Pmax will be 0. So 0 power will be dissipated. So now I will say you. So you had you in the beginning itself you said that this is balance bridge, right?
Yeah.
So in a balance bridge, that means it's a short circuit or open circuit. So you can directly tell the Pmax will be 0. If they are asking across this particular part, then only, because this in a balance bridge we have a power to do short circuit or open circuit. Okay.
If the diagram is balanced, we can neglect that middle part.
Yeah,
So
we can neglect.
Pmax will be 0.
You can neglect it. You can open it or you can short circuit it. It's up to you.
Yeah.
So if you short circuit it, that means there is a no voltage difference. This is short circuited, means VAB is 0. Okay, and if VAB
So no power.
so no power will be there. Correct. Okay, so there will be a no power. Now you have a question, means you need to find the, okay, the next question is, just practice 2-3 questions, then we'll go for another topic and then we'll move for a transient. So suppose you have a 2 ohm, this is your 4 ohm, this particular is R ohm, and this is positive negative 10 volt. So in the question they had mentioned this particular is your RL part. So you have to replace this circuit like this, means this 4 into R divided by 4 plus R, and you have to consider this is my load resistance. In the questions they had mentioned like this is your RL. Okay, so you need to do like this. So this is your 2 ohm, this will be 2 ohm, and this particular will be 10 volt, and this is your RL. So directly we are watching this circuit VTH, we directly, if we'll go from this point, we are directly know the VTH is 10 volt. Okay, and RTH will be 2 ohm, only this part na. See, 2 ohm, positive negative 10. You are watching from this, you need to find the value of a VTH. The current is 0, apply this and get the result. Minus 10 plus VTH is equals to 0. So VTH is coming as what? 10 volt. And if you, for RTH, you need to short circuit and see the resistance. You are getting the RTH value is what? 2 ohm. Okay, so if my RTH is 2 ohm and my VTH is 10 ohm, so for maximum power theorem, what is the what is the condition? Your RTH should be equal to your RL. Okay. So what is our RL? RL is 4 into R divided by 4 plus R. And what is your RTH? RTH is 2. So this will be 8 plus 2R is equals to 4R. So what value you will get? 2R. R value you will be get 4. Is this clear? Is this clear, guys? See, we have to watch from here. They had said that you need to calculate the load. This is our load. The whole is our load. So we need to consider RL as the parallel combinations of 4 into R divided by 4 plus R. We know that after considering this, we calculate the VTH value. VTH we are getting as a 10 volt and RTH we are getting as a 2 ohm. Now, for maximum power, this 2 ohm will be equal to this RL. We derived it now only, and the RL value, we know that RL value is parallel with 4 with R. So we need to find the value of R. We need to equate it, and we will get the value of R as a 4 ohm. Prasanna, got it?
Yeah.
Okay. Priyanka, you are understanding these things? See, we have
Clear, sir.
like 100 ohm, and this is my 200 ohm, and this particular is my 50 ohm, and this is your positive negative VL. Okay, what they had asked in this particular question, this is my positive negative 20 volt. You need to find the value of a VL for which power will be maximum. Okay, and they had also mentioned this whole is your load. Okay, guys, if this whole is my load, I am considering this whole part as my resistance. Okay, so I am replacing this circuit 100. This particular is my RL,
RL.
and this is positive negative 20 volt. So what is the VTH value? 20 only. And what is the RTH value? 100 volt. Right? 100 ohm. RTH will be 100 ohm. If you want to calculate, just open it and do the KVL. If you'll open this RL part, you will get the current as a 0. Minus 20 plus 0 into 100 plus VTH, you will get the VTH value is 20 ohm. And if you want to find the value of RTH value, see from here and do the short circuit, you will get the 100 ohm only. So you are getting a 20 volt and a 100 ohm. Okay. Now what I want to say you, we have a circuit 200 ohm. This is my 50 ohm, and this is my positive negative VL. Okay, guys. So here we have to understood now. This is the whole circuit is 100 ohm. It's representing our 100 ohm. So suppose some current is going from here. Some current is going from here. So VL divided by VL by I. Okay. So if you here we have to find the value of a VL. So how can we find the value of a VL? This is my 200. So we need to find the value of a VL. So how can we do it? Guys, how can we do it? You can suggest how can we do it? And we know the value of a RL will be 100 only, according to our maximum power theorem. So how can we do these things? How can we do these things? Okay, let me tell you. It's very easy. Suppose your RL value is how much? This is 100, so RL value will be 100 only. Find the value of a current. How much current you will get? 20 divided by 200. So you are getting 1 by 10 ampere current. So that means from here, how much current is traveling? 1 by 10 ampere current is traveling. 1 by 10 ampere 1 by 10 ampere current is traveling from this part. Okay, if this is 200, if this particular is 200, that means how this whole part will be 100? If we have a 200 parallels resistance, then only it will make you 100 now. So that means this all represents, this overall represents a 200 circuit, 200 ohm circuits. So if 1 by 10 current is here, so 1 by 20 will go in this path and 1 by 20 will go in this path, right? If you know the value of a 1 by 20, 1 by 20, you know the value of a 1 by 20, this is my 1 by 20. So what is the voltage you will get? 200 into 1 upon 20, so 10 volt. So positive negative 10 volt you are getting. Apply the KVL. 10 minus VL by 50, you are getting 1 by 20. So how much value you will get? 10 minus VL, 2.5. So VL value you are getting 7.5 volt. We got the answer, 7.5 volt. So it is not that much tough. Okay, it seems to be a tough question, but it's not that much tough. See, what I will tell you once again, because I know you guys not understood these things. See, we have a particular circuit like this, 100 ohm. This is 200 ohm. This is 50 ohm. This particular is positive negative VL. This is my positive negative 20 volt. Okay, so if the circuit is like this, 20 volt, so, and here we are considering this is my overall load RL, and by seeing this series circuit, this represent my VTH part and this represent my RTH part. So for maximum power, what is the conditions? RTH is equals to RL. So we are making the circuit like this, 100 ohm. This is my 100 ohm. This is positive negative 20 volt. So what is the meaning of this? How much current is flowing in this? 20 divided by 200.
1 by 10.
So 1 by 10 current. 1 by 10 current. So means these 100 it's representing 1 by 10 current. Okay, and this overall is your 100 ohm resistor, right? So you have one parallel 200 resistor, and suppose this 50 ohm plus VL, I am just considering 50 ohm plus VL as my R. So 200 into R divided by 200 plus R is equals to 100. If you solve this, the R value will come how much? R value will come how much? If you solve this, 200 plus R, 200 plus R is equals to 2R. You are getting the R value is how much? 100 only. So these particular things, when these particular things will be 200, sorry, it will be 200. So when this particular thing will be 200, then only you will get na RL as 100. 200 into 200 divided by 400 you are getting. So this VL, this you are confused with this VL. Actually, plus minus V of L, this plus minus V of L, and suppose some current is passing through this. So VL by I, we can replace this VL, this particular this VL by I potential as a, we can replace like this. We can make this things like this as a resistor, VL by IL. It's up to you. You can make it like this as a resistor. So when IL current will come, it will give the voltage of a VL only. Okay. So apply the current division rule. This is your 1 by 10. This is my 200. This particular is also my 200. I know this will be 200. Okay. So guys, or you have one option, you have another option. Yeah, you can do with this way also, or you have another option. I will tell you. If you are not comfortable with this part, you have another option. 100 ohm, this is your 200 ohm. You know the value of a current as a 1 by 10. This is 50, and this particular is positive negative VL. So if you are comfortable with this, suppose this is my V value. Okay. Now this particular positive negative, I know it's 20. So apply the KVL and get the V value. Minus 20 plus 100 into 1 by 10 plus V is equals to 0. So what the value of a V you will get? 20 minus 10. So 10 voltage is coming. So here 10 volt. So V is your 10 volt. So if V is my 10 volt, what will the current? 10 divided by 200. 10 divided by 200 is 1 by 20. If this is my 1 by 20 current, so apply the KCL. If 1 by 10 current is coming, I am getting 1 by 20 current, so plus X. So X will be 1 by 10 minus 1 by 20. So here also 1 by 10 current will come. And you need to find the value of a VL. So 1 by 10 minus VL divided by 50 is equals to 1 by 10. You can do like this also. So how much you will get? 1 minus 10 VL, that will be 5. That will be actually 50. Oh sorry, I did some blunder, I think. This will be 1 by 20 na? 1 by 20. It will be 1 by 20. So V minus VL divided by 50, you are getting 1 by 20 current. So V minus VL is 5 by 2. 5 by 2 value is 2.5. So VL and V value you got 10. 10 minus 2.5, you are getting the VL value. VL value is 7.5 volt. You can do like this also. It's up to you. Prasanna, understood? Prasanna, understood?
Yes, sir.
Okay. So that was not a tough question actually. It was a very easy question. The same thing they had asked many times, Many times they are asking these questions like this. Oh, just wait for a 2 minute. Let me connect my laptop. Just wait, guys. Guys, my voice is coming.
Yes, sir.
Okay. So what I am telling to you. So suppose you understood these questions, these things. It's clear, or any doubt? Okay. If it is clear, then fine. We can go for the next question. Wait. Priyanka, my voice is coming. Is it coming or not?
Yeah, it's coming.
Okay. So actually, I have some issue with net. That's why I asked you. So see, what I wants to tell you, we have some complex network connections. Some complex network, or we'll solve this in a workbook problem. Leave it here. Leave this question right now. So next topic is write the next topic. Next topic is maximum power transfer theorem in case of AC circuit. In case of AC circuit. So in AC circuit, practically what you have ZTH, and the load will be ZL, and your V will be VTH. Okay. So ZTH is what? What is representation of ZTH is? ZTH is RTH plus JXTH, and ZL is what? RL plus JXL. So guys, what will be the current of I? I will be equal to VTH divided by ZTH plus ZL. This ZTH plus ZL, you will get the value of I. And if you solve this particular VTH and ZTH, what you will get? VTH divided by ZTH means RTH plus JXTH plus RL plus JXL. Put the real term one side and imaginary term one side. You will get what you will get, guys? What you will get if you will put the real terms one side and imaginary terms one side? What the things you will get?
Take the J common, XTH plus XL plus RTH plus RT.
Okay. So you will get, okay. So you will get RTH plus RL one side, and you are telling that J will be like this, XTH plus XL. You are telling like this.
Yeah.
It will be like this. Okay. So what you are telling, it's correct only. So see, So you are getting the value of means you understood how we calculated this I value. I value is VTS divided by ZTS plus ZL. And what is the value of my mod I? Mod I value VTS divided by root under RTH plus RL whole square plus XTH plus XL the whole square. Correct, guys? So what is the power actually? Power is nothing but power is mod I the whole square into RL. So suppose means you were having a ZTH. This is your RTH and this was your JXTH. And you have a RL load and this was your JXL load. So useful power will come across what? It will come across RL only. This will, the average power of this will be 0. I thought you this thing in previous classes. Either it will be a capacitor or inductor, the average power of this reactive part will always be average power. But if anyone is asking about the real power, what you are doing, you are finding the value of a current, you are squaring it and you are multiplying with the RL load, RL value, right? So this is my power. Now if you will put the value of these things like VTH square into RL divided by RTH plus RL whole square into XTH plus XL whole square, you will get, this is your equation 1. Now you have to find the value of the relations value. Now there will be a many case. So in a first case you will assume, let you have a variable inductor. So if variable inductor is there, then we'll do dou p by your RL is fixed and but you have a variable inductor, then we will do dou p by del p by delta XL. If you will calculate this value, what you will get? VTH square into RL, that part is constant, so you will get minus 2 XTH plus XL divided by RTH plus RL whole square plus XTH plus XL whole square, the whole square is equals to 0. So what is the relations you are getting? This all will be 0, means you are having a one relation XTH is equals to minus XL. So this condition is true for when RL is fixed but your XL is variable, then your XTH should be equal to minus XL for power transformation, for maximum power transformation. Let's assume the second case. In this second case, your XL is fixed, so we have a conditions dou p by dou RL. So dou p by dou RL means your RL is not fixed, your RL is variable. So then what you will get the result? You will get VTH square, that will be common, RTH plus RL whole square minus 2 RTH plus RL divided by RTH plus RL the power 4. Okay, you will get RTH plus RL square plus XTH plus XL whole square is equals to 0. So what value you are getting? what value you are getting? You are getting this particular value. So if you equate this, if you equate this, uh, yeah, if you equate this particular value, let me just write it from the beginning, then only. So suppose you have a power at power is what? Power is equals to mod I square into RL. What is I value was VTH square divided by RTH plus RL square plus XTH plus XL square into RL. Now what I am telling in these conditions, I am doing dou P by dou RL. Okay, so if you will do dou P by dou RL, what you will get? VTH square, differentiation of this will be that only, RTH plus RL the whole square plus XTH plus XL the whole square minus RL into 2 RTH plus RL, and this part will be 0. Okay guys, and this is RTH plus RL the whole square plus XTH plus XL the whole square is equals to 0. So see this result and just tell me what is the value of a RL you are getting. Your load resistance will be equal to what? This is your 2 RL into 2 RTH plus RL, and this is RTH plus RL the whole square plus XTH plus XL the whole square. Okay, so and one thing is that here you are assuming, here also you are assuming XTH is equals to minus XL. This particular things you are assuming, so this will be 0, this will be 0. So VTH square you are getting RTH plus RL the whole square minus 2 RL into RTH plus RL divided by RTH plus RL to the power 4. We are assuming the first condition, that my XTH is equals to minus XL. I am assuming the first condition. That's why if I'll put this thing, so XTH minus XL will be 0, XTH minus XL will be 0, and when I will take RTH plus RL, it will get cancel out, it will become 3 and it will become 1. So you are getting what? RTH plus RL minus 2 RL is equals to 0. So your RL value is coming as a RTH value. So what you had understood guys, this is the crux. So if you have, means this is your network, suppose this is my RTH value, this is my J XTH value. For maximum power transfer theorem, this value, this XTH value should be opposite to this, means here XL must be equal to minus of XTH, and this RTH value should be equal to this is RL. So what is the things, if you are having a ZTH is equals to RTH plus JXL, your ZL should be equal to ZTH conjugate, ZTH conjugate, that means RTH minus JXL. So for finding, suppose for finding the maximum power transfer theorem, you have 5 J5, you have 5 or J5, then this particular things, you have ZTH is 5 J5, ZTH is 5 plus J5, that means your ZL should be how much? Conjugate of ZTH, 5 minus J5 means what? You have one resistor of a 5 ohm, but you should have one capacitor of minus J5. Is this clear? Is this part is clear for everyone? So this is very much important. Your ZTH should be equal to ZL. ZTH conjugate means your ZL should be equals to ZTH conjugate. So remember this point. Remember this point. If you have RTH plus J XTH, here your RL should be equals to RTH minus J XTH. That's it. Positive, negative. So how much power you will get? VTH is equals to, this is your VTH. So VTH, okay. What current you will get if you will substitute in this? What current you will get? VTH divided by RTH plus JXTH minus JXTH. So this particular get cancel out. You are getting the VTH value to RTH. So what is the power you are getting? Power is nothing but I square into RTH. This RTH. Actually this is RL value. So RL is nothing. RL is equals to RTH only. So you will get the same result. VTH square divided by 4 RTH square into RTH. This RTH will get cancelled out. So you are getting the same result. VTH square divided by 4 RTH in AC also. Guys, is this clear? Prasanna, understood?
Yes, sir.
Okay. See, now there are many other cases. This was one case I told you. Now write the case 1. Case 1. You just need to differentiate it and get the result. When both RL and XL are present, but only RL is variable. The earlier case was both RL and XL was variable. Okay, this case was, in this case we have both RL and XL both are variable. This was also variable and this was also variable. So for finding the maximum theorem now, maximum power theorem now, we did separately. We just assume first our RL is variable, first our XL is variable, RL is constant. Then we find the XL is constant and RL is variable. We just put the value of XL and we got the result. Now the different case. This is the different case. We have both RL and XL are present, but only RL is variable. Means you have a load RL and XL. This is your JXL, this is your RL, but this is not variable. This particular is variable, and this here you have RTH and JXTH. Then in this case what will happen? Okay, so in this case power is the same only, VTH square into RL divided by RTH plus RL the whole square plus XTH plus XL the whole square. Now you just have to differentiate dou P by dou RL. If you will differentiate dou P by dou RL, and you don't need to put the value of XTH is minus XL. So if you will do the differentiation, what you will get, guys, what you will get, VTH square, RL is differentiable, so RTH plus RL the whole square plus XTH plus XL the whole square minus this is this is variable, this is not variable, so it's constant. So you will get minus 2 RTH plus RL, and all RTH plus RL the whole square plus XTH plus XL the whole square power 4. XTH plus XL whole square power 4 is equals to 0. So if you'll equate it now, you will get one relations, that is RTH plus RL the whole square plus XTH plus XL the whole square, and here RL will also come. So RL value minus 2, because we are differentiating now, so this RL value will also come. So you are getting 2 RL into RTH plus RL. Okay, so you need to find the value of this particular thing, and you have to equate, and you need to find the value of RL value from this particular thing. So guys, you are getting, see, VTH square into RL divided by RTH plus RL the whole square plus XTH plus XL the whole square. VTH square is common. You are doing the differentiations and you are getting the result like this. This minus is coming. This RTH square plus RL the whole square is coming. Okay. So if you'll solve this circuit now, if you'll solve this particular circuit, and if you will find the value of RL, so the RL value will come root under RTH square plus XL plus XTH the whole square. You will get the result like this. You will get this particular result, RTH square plus XCL plus XTH the whole square, if you will solve this particular circuit. Let me solve it for you. Suppose this will be RTH square plus this particular will be 2 RTH into RL plus RL square plus XTH plus XL the whole square. This is 2 RL RTH plus 2 RL whole square. So this particular things is getting cancelled out. This you are getting as a RL square. So what is the value of a RL you are getting? Root under RTH square plus XTH plus XL the whole square. Okay, now see, what is the meaning of this? You have RTH, you have XTH. This RL value we don't know. This RL value we don't know, but we know the value of XL. So what will the value of a RL for a maximum power transfer theorem? If my XL is fixed, then it will be root under this particular RTH square plus summation of this and this, XTH plus XL the whole square. Guys, I hope you understood. Prasanna understood how we got these things. Okay, now assume the case 2. In a case 2, when the load impedance purely resistive, okay, it is given like this. You have RTH, you have XTH, but your load resistance na, you are having purely ZL is R plus J XL, but this XL value is given as a 0, means it's purely resistive. If it will be purely resistive na, then what you will get, your ZL value will come, your ZL value will be root under RTH square plus XTH square only, this square plus this square mod of. How so? Do the differentiation. Power is equals to VTH square divided by RTH plus RL whole square plus XTH plus XL the whole square into RL. But you know the XL value is 0. It is purely resistive. Okay, so you are getting the power equations VTH square into RL divided by RTH plus RL the whole square plus XTH square. Do the differentiation. Dou P by dou RL and make it as a 0. Dou P by dou RL and make it equals to 0. So if you will make it equals to 0, VTH square, what you will get? RTH plus RL the whole square plus XTH square minus RL into RL. Rest everything will be this. This RL is coming, and if you will differentiate this, you will get minus 2 RL square. Okay. Yeah, and it will be 0. So if you'll solve this particular thing, and this particular is RTH plus RL the whole square plus XTH the whole square. So if you'll solve this particular thing, what value you will get? RTH square plus 2 RL RTH plus RL square plus RL square plus XTH square goes to 2 RL square. Okay, I guess I missed some point. Oh, this will be into RL plus RTH. RL plus RTH. So you will get 2 RL square plus 2 RL RTH. So this particular thing will get cancelled out. This will get cancelled out, and you are getting RL value is root under RTH square plus XTH square. So this is one condition. Okay, so this is the many condition. Now make a table. I will tell you one thing, so you don't have to do the derivations again and again. See, for AC circuit, see, make a table like this. This is your ZL when both are variable, when RL plus JXL both are variable, then your ZL should be equal to ZTH conjugate. Okay, when both are variable. This is first case, case number 1. Case number 2. In case number 2, you have variable means it is variable and this particular is variable. Then it should be like this. So ZL is Z conjugate. When you have ZL is equals to when RL plus JXL is there, but your only RL is variable, then the value of a RL will be equal to root under RTH square plus XL plus XTH whole square. Number 3, when you have a ZL value as a purely resistive XL, then directly you means purely resistive means XL value is 0. You can directly put the XL value is 0 and get the value of RL, that is root under RTH square plus XTH square. So you are getting the RL value is mod of XTH. So this is the 3 conditions you have to know. First condition, second condition, that is the third condition. Is this clear to everyone? Okay. Now suppose there is one special case. What is the special case? It is a very special case.
Next, previous slide, Kanishwar.
Next.
Previous slide.
Oh, previous slide. Okay, this one.
Yes. Yeah.
Okay. When you wrote, just tell me.
Completed, sir.
Okay, if it is completed, then it's fine. Yeah, only few parties left. We'll move to the transient part. So first, just try one question. We'll try one question in a AC na. Then we'll go for the AC a special part. Okay. So the question is, suppose you have a network like this. This is my network. Oh, this particular is my network. This is 110 at an angle 0 degree. This particular is 90 at an angle 0 degree, and the value of this is given as a 6 plus j 8 ohm, and this it is given as a 6 plus j 8 ohm. And here what they had asked you need to find the, here they had mentioned ZL is equals to RL. So if this is the condition, means no reactive part is there, means ZL is only RL, there is no 0 XL, means you have only this part. So first you need to find the VTH value. So how you will calculate the VTH value? So open the circuit like this, this particular is your 110, this particular is your 6 plus j8 only, and this is your 6 plus j8 only, and here I am assuming this is my 0, and here I am assuming VTH. So you need to find the value of a VTH means just find the current, or this is also as 90 at an angle 0 degree. So and this is 100 at an angle 0 degree. So what will the current, if you use the equation, so 110 at an angle 0 minus 90 at an angle 0 divided by 6 plus 6 12 plus j 16. So my current I am getting like this. So 110 minus 90 will be how much? 20 at an angle 0 divided by 2, take common, 6 plus j8 only, so it's 10. So I am getting the current at an angle 10 0 divided by 6 plus j8. So what will be the VTH? If I want to find the value of a VTH, I am taking this particular path. I know the current, so minus VTH plus 6 plus j8 into I plus 90 is equals to 0. So VTH value you will get 90 minus, you will get VTH value is summation of this. So VTH value you are getting 90 plus 6 plus j8 into I. So VTH value how much you will get? 90 plus 6 plus j8 into 10 at an angle 0 divided by 6 plus j8. This will get cancel out. So VTH value will get 90 plus 10, 100. So we got the value of a VTH, right? 100 at an angle 0. And what about the ZTH value? ZTH value, for finding the ZTH value, you need to short circuit your voltage source. You are watching from this side. So this is A, this is B. So it is also connected to A to B, it is also connected to A to B. Means both this and this are in parallel. So your ZTH will be 6 plus J8 into 6 plus J8 divided by 6 plus J8 plus 6 plus J8. You just directly, because this is the same element, this is the same element, so directly you divide by 2, you will get 3 plus J4. So this is your ZTH value. So you got the value of a VTH. We got the value of a VTH is 100 at an angle 0. We got the value of a ZTH. This is 3 plus J4. So for maximum power we have RL. We don't have a XL. So what will the RL value? Root under 3 square plus 4 square. We are using the third conditions. This is the third condition, when ZL is equals to RL only. So root under RTH plus XTH square. So you are getting the value of a RL is how much? 5. So RL value will come, how much? It will come 5. So RL value you are getting 5, but here you have to find the value of maximum power theorem, means maximum power. So guys, this is my ZTH, this is my VTH, that is 100 at an angle 0, and ZTH it is 3 plus J4, and R value we got 5. So find the current, how much current it will flow. I will be how much? I will be 100 divided by 3 plus J 4 plus 5. So I will be 100 divided by 8 plus J4. So if you solve it, how much you will get? 25 divided by 2 plus J. So 25 divided by root under 5. So 5 root 5. I am not writing any angle because I need the mod value only. So 5 root 5 value I am getting. So what is the power? Power is I square into R. So if I am getting I is 5 root 5, then 5 root 5 the whole square into R value is my 5 only. So 25 into 5 into 5. So 25 into 25 is 625 watt. This is my power. Is this clear, Prasanna?
Yes.
See what I did now. We have a 110 voltage here, 90 at an angle 0 degree here, and this is my load. So that means I have to open this one. So I have these things, and the current is in this will be 0. So I will find the value of a current, and I get the value of a current that is 10 at an angle 0 divided by 6 plus J. After finding the value of a current, I just applied node means a KVL minus VTH plus 6 plus J8 into I plus 90 at an angle 0. From here I get the value of a VTH, that is 100 at an angle 0. For finding the value of a RTH, I need to short circuit this path, and I have to see from here. This is also A, this is A, this is B. So from A to B one connection is there, from A to B another connection is there. That means these both two are in parallel. So this is also same, this is also same. In a parallel, if the resistance all the elements are same, so it will automatically get divided by 2 if 2 branches is there. If 3 branches, then it will be divided by 3. It's depend. So here 2 branches is there, so 6 plus J8, 6 plus J8. So what will the equivalent resistance? We'll get 3 plus J4. So we got the equivalent ZTH value, and in the question itself they had mentioned that ZL is only only RL. So we'll apply the third condition. The value of RL will be what? RL will be mod of ZTH. So mod of ZTH, we find the mod of ZTH. Okay. So mod of ZTH, we got the value of RL value is mod of ZTH. So ZTH is 3 plus J4. So RL value will be 3 square plus 4 square. We got the value of RL 5. Now we know all the value. So you need to find the power across this. So for finding the power across this, what you need to do? You need to find the current. So I just solve the current. 100 divided by 3 plus J4 plus 5. So I got the current value, only the mod value. I am not considering any angle. I am not taking any angle. Angle will be there, but it's not used for me. So I got the value of a power current as a 5 root 5. So I know in this circuit how much current is flowing. 5 root 5 some angle 5. 5 root 5 at an angle, some angle will be 5. Just solve it and get the angle also. But I have a resistance here, so I just need to square it with this and I will get the my maximum power. So I got my maximum power as a 625 volt. Is this clear for everyone? Priyanka? Prasanna?
Sir.
Okay. Now if it is clear, you are ready for the special case. So this is the last topic of maximum power theorem. And after that you have only one chapter of network. Special case when source resistance is variable. This is the special case for maximum power transfer. So your RTH is when your RTH will be variable. When your RTH will be variable. Positive, negative. That is your VTH. Then what will be the condition? What is I? VTH divided by RTH plus RL. Right. So what will the power across this? I square into RL. So power will be VTH square divided by RTH plus RL square into RL. So you got the power value. P is equals to VTH square into RL divided by RTH plus RL square. So you got the value of a power. What will be the equation then? My RTH is variable. So I will do dou P by dou RTH. So if I will do my dou P by dou RTH, this all are constants, I will get minus VTH square into RL. This will be 2 RTH plus RL, the 2 into RTH plus RL. Yeah, that's only. And I will get RTH plus RL the whole cube. This value will get cancelled out. So and it will be equals to 0. So guys, we are getting a something equation like this: 2 RL divided by RTH plus RL cube. So here no RTH value we can able to find. So simply our RTH value will be 0. RTH value will be 0. Okay. So for this kind of network, our RTH value we need to put the 0. And one thing also, suppose your I is what? I is VTH by RTH plus RL. If my current will be high, then only the power will also be high. If current value will high, then only the power will high. So how can I make the current value high? And if I have a power to do anything with RTH, if I'll make this RTH as a 0, then automatically the current will get high. If RTH value, if I'll increase up to certain value, then what will happen? The power will get decreases. If I'll decrease this RTH value up to 0 only, we can go na. Beyond this, the negative value will come. That's why I will directly take my RTH value is 0. If this kind of a network is there, when RTH is variable, so just assume that RTH is 0. Is this current? Is this clear? Or in this you don't do RTH is equals to RL. This is wrong. When your RTH will be variable. Okay, guys. Is this part is clear? Like suppose you have a questions. I'm giving you one basics question. Then it will be automatically clear. And for P max in this kind of a circuit, you will get VTH square divided by RL only. Like this was the gate 2015 question. This is 6 ohm. They had R, and it's having positive negative 10 volt, and this is my RL is equals to 3 ohm. So guys, this particular part is my RTH, this is my VTH. So here something is given that R is parallel to 6. So we will assume in this kind of a question, we'll assume what? We'll assume in this kind of a questions, my RTH is 0. So if it is 0, then what is the value of R? R into 6 divided by R plus 6. So what is the value of R I am getting? 0 only. 0. So the circuit will be like this. In this case only you will get the maximum power. So it will become, it will replace by a short circuit. So you will get maximum power how much? This is 3. So 10 by 3 my current I am getting, and power will be 10 by 3 the whole square into 3. So 100 by 3, that is 33.33. Is this part is clear? You understood this part? Prasanna, Priyanka? Yeah. You understood? So congratulations, we had completed a vast topic of network, and now it's like a last chapter. You can say it's a last chapter, but there are some other parts. That's not a huge part. This chapter is chapter 5, transient analysis. And this will study what about the resonance circuits and all, everything will study. We'll study the tank circuit. So transient, this is the transient. Okay, so in a transient we do steady state analysis. What is steady state analysis? Source free RL network, RC network. Okay, and energy concentrations will study. RC network, about RC network will study. So this is a very interesting part of the network. And yeah, in this also you have a natural response. Let me check the syllabus, what the things I have to teach you in this. Separate two source, okay, time constant and all. Yeah. So actually this chapter means, this is the combination of a two chapters. So we have a transient, and the next chapter is your, you can say, resonance. So this is the extension of this chapter only, resonance. And all are interconnected, that's why I'm saying that it is the most important part. And the transient is only the vast topic. And then you will have a graph theory. So this is a very simple topic, graph theory. After graph theory, and a small part will come as a filter and magnetic circuit. So it will consume, I think, 3 to 4 classes. It will consume 2 classes. This will consume 1 class, and this will consume 1 class. So we can say that 4 to 6, 7, 8 class. So 8 to 9 classes, we can say 8 to 9 classes. In 8 to 9 classes, your network will be over. Okay. So this is the new topic, transient. So that's why I'm not starting now, because if I'll start, uh, I will start it tomorrow. From tomorrow onwards, we'll start this transient part. Okay, guys. So just you have to do one thing. Means like, whatever the topics you are studying now, just try to make one short notes. Okay, make one copy, and in that copy try to finish whatever the things what I told you. Whatever means like, what the formula you will not able to recall. So that kind of a formula you make as a 1 2 formula 1 formula 2 3 formula 4, like this. Means in a chapter 1, so what was the basic part? Nodal analysis. What is the nodal analysis? What is star delta conversion? How we are doing in a two port network, AC, that symmetry, asymmetry, reciprocity condition. So you just make a chart and write it by yourself. I already shared you my notes with you guys. You can take a reference from that notes, because all the whatever the things I had taught you here with that notes only. Okay, so you can use that notes for your study purpose and for making the short notes, because if you will not make the short notes, you will face lots of difficulties in the main examinations, because the things will be a very vast. See, in a network itself you are seeing that the syllabus is going to be a very vast. It's not very vast topic. You need to do continuous revision for cracking it. Is, it's required continuous revisions. Continuously you are studying that part. Okay, if you are studying the first chapter, second chapter, third chapter, if see, everyone forget, even I am forgetting the things. So you have to do these things. Means like, give 7 days. Okay, I will revise the first chapter for 2 hours, then second chapter for 3 hours, like that you have to do. This is your periodic revisions. What we say, it as a periodic revision. So in a first revision it will take a lots of time, a large amount of time. But when you will go for the second revision, it will take less time. For your revision, it will take a few times. So how it will come? In your first revision you will make one short notes. From that short notes you will understood, oh, this is only I have to remember. Okay, suppose it's taking a 7 days for one revision, it's taking you for 3 days, and it will be like in a 1 days only you will revise all the network. So it can be possible only by making the short notes. To try to make the short notes. Okay, guys. Okay.
Yes, sir.
Good night.
Good night.